Good morning and welcome to something that maybe we haven't really done before here in year 11, but we're going to look at it today. What I'm going to do is I'm going to do a couple of examples of questions. I'll explain the questions and therefore hopefully you'll understand them. And then what I'll ask you to do is for you to do the questions on an A4 page, upload them to me and I'll mark them. So the onus is back on you again. I'll be recording these. What they're used for, well, time will only tell. So I'm going to look at page 409. I'm going to look at Test Yourself, chapter 34, pages 409, 411. And I'm going to do questions 1 to 5. So that's what I'm doing. So let's just write down so you know what we're doing. We're going to do Test Yourself. It's also, and it's chapter 34. So in the book, you know where it is. And the questions are on page 409 and 411. And in this book, sometimes the questions are hidden up on the left-hand side of the page. Sometimes you can't see them. So I'll do these questions as best I can for you. Then you do them on an A4 page and you upload them to me and I mark them. Again, these are all marked, recorded, and they're time-bound because I'm not going back over to mark them all over again. So we'll look at number 1 here. It says an atom contains electrons, protons and neutrons. Which of these particles are outside the nucleus, are uncharged, have negative charge, are nucleons, are much lighter than the others? So let's have a look at it. So we'll draw one. Again, there's the nucleus. And the nucleus contains nucleons. And the nucleons, well, there's 2 of them. There's the protons, and they're positive. And there's neutrons, and they're no charge. Right, so that's that one. And then on the shells, again, this is not drawn to scale. You have the electrons. And it says an atom, so we're going to assume that this is a neutral atom. So remember to do the pen bit here. There's always the same number of protons as electrons, and the neutrons and the protons give you the number of nucleons. And also remember A cross zebra. This one gives you the number of neutrons. Sorry, that is rubbish. This one gives me the number of protons. This one gives me the number of nucleons, which are protons and neutrons. So I'll just do a quick example here. Here's the suit on Santi's suit. This tells me it's got 6 protons. This tells me it's got 12 nucleons, and the nucleons are the protons, following the machine, and neutrons. So this tells me it's got 6 protons and 6 neutrons. Fair enough? So now let's answer these questions. Are outside the nucleus? Well, let's have a look at the diagram. The electrons are outside the nucleus. So that's the answer to A. So you could write this down. Again, you're doing the answer, not I. Are uncharged. The only uncharged ones are neutrons. They're over there, the neutrons. Have a negative charge. The negative charge are the electrons. Are nucleons. Well, the nucleons are the things found inside the nucleus. And E are much lighter than others. The electrons are roughly 1/2000th, or probably 1/1836 of the mass of either a proton and neutron, because they're taken as the same thing. They're taken as the same mass, and that's the wee skinny fella. Fair enough? So I have done down question number 1 there, so you should be able to draw that. And in clear sentences, answer A, B, C, D, and E. Fair enough? So that's number 1 done. So let's have a look at question number 2. It says, how many protons, neutrons and electrons are in the nucleus of carbon-14? So let's write down the carbon-14. This is the upmarket brother of this chap up here. Right? There's your carbon-12. This is carbon-14. It's an isotope. We've done isotopes. So let's do our bit of work here. It's got 6 protons. Right? It's got 14 nucleons. Remember, A cross zebra. So that tells me it's got 6 protons. How do I know that? Because it's down there. And something added to 6 gives me 14, so it must be 8 neutrons. Fair enough? So now we have all our spade work done. Now we can answer the question. How many protons? So let's do pen. You can write a full sentence. So it's got 6 protons. It always has the same, if it's a neutral atom, it always has the same number of electrons as protons. It doesn't tell us it's an ion, so we assume it's a neutral atom. And then 6 and 8 gives me 14. So there's got 8 neutrons. Fair enough. That's question number 2 done. Now going on to question number 3. Again, quality of answers. Practice the quality of your answers. Do good work. In the exam, you'll do good work. Do rubbish now. In the exam, you'll do rubbish. The element sodium has the chemical symbol Na. So we'll write that down for a start. Sodium. In a particular sodium isotope, there are 12 neutrons. There's 12 neutrons. So P, E, N. I know there's 12 neutrons. In a neutral sodium atom, there are 11 orbiting electrons. 11 electrons. So there must be 11 protons. So, can we fill in the 2 numbers? The atomic number is the number of protons. Remember, A cross zebra. So the number of protons must be 11. Fair enough. Where did you go? They're back. And then don't forget the nucleon number, the atomic mass. 11 and 12 is 23. So that's the symbol of it. Fair enough. That's question 3 done. And question number 4, again, a full sentence. Full sentence. Now, you'll see me get up to the corner here. The reason I got up on the corner here is I'm not going to waste pages upon pages of this special paper. So you should be continuing down the page. I want to see this continuing down the page. If you have to upload 2 A4 pages, so be it. In what way are the nuclei of isotopes the same? So, isotope, let's write down the answer. An isotope, same atomic number, different atomic mass. Remember, A cross zebra. And the good ones that I always put down to remind myself are carbon 12 and its fancy brother, carbon 14. So an isotope. Same atomic number, the number at the bottom. Different atomic mass. That's the number at the top. Right? So it's got the same number of protons. That's the number at the bottom. Different number of neutrons. Of nucleons. Clown. Different number of nucleons. Not fair enough. So that's a nice one. Let's just go up and have a look at this one. Follow the blue spot. There's the carbon 12. The carbon 14 is not too well on that screen, but it's on my page. It is. Is that any better? Yes. It's got the same number of protons. Follow the blue spot, but it's got different number of nucleons. See that? 6 protons, 8 neutrons. 6 protons, 8 neutrons. 6 protons, 6 neutrons. Fair enough? Right, now where am I going to? I'm going, that's question number 4 done. Now I'm going to question number 5. Question number 5. Name a radioactive isotope that occurs naturally in living things. Well, I have news for you. You're a living thing. And it's, the answer to that is carbon 14. Most of the things that we know living are based on carbon. So there's the symbol for carbon 14. And let's do the PEN then. It's got 6 protons. So therefore it's 6 electrons. And 6 and something gives me 14, so it must have 8 neutrons. Fair enough? Now I'm not going to copy this table in. You can copy the table. Now, I want the table perfect. I want the table to look like that table. And it's quite difficult, but I'll go down through all the answers of it. So we're looking at the property of these things. So property, nature. Each particle is made up of, so there's your alpha and there's your gamma. So beta particles are fast-moving electrons. Relative charge. Now relative means to each other. So if a beta particle is -1, the proton is +1. They are the same size of charge. They are not the same mass of particle, but they have the same size of charge. Fair enough? And your gamma rays have no charge. Fair enough? Let's go to the mass. Remember, the alpha particles are big, the beta particles wee, and the gamma rays have no mass at all. The speed, right? Up to 0.1, so it's roughly a tenth. Beta particles, up to 0.9 times the speed of light. Fair enough? And penetrating effect, well, alpha particles penetrate a few centimetres of air. So, I want that table copied, perfect, and uploaded to me. So, let's recap what I want. I want you to go to this mind map that I have done here, this talking mind map. It shows you how to do the questions. So you do the questions 1 to 5 inclusive to a high standard. You take a plan view of them and you upload them to me, and I will mark them. Again, I am recording this and I am time bounding it. But if you don't have it finished, you don't get the mark. Thanks very much. That's Test Yourself Chapter 34, questions 1 to 5 done. I look forward to seeing your work. Thank you.